Okay, so the trigonometric functions of the sine and cosine can be used to model and understand certain scientific phenomena of our planet. Through modeling with sinusoidal functions, we learn more about the behavior of our Earth and universe. In this project, we try to model the patterns of sunspot activity.
Now we are going to explain our project. Sunspots are relatively cool regions on the sun that appear as dark spots when we observe them through special solar filters. The number of sunspots varies in an 11-year cycle. The table gives the average daily sunspot count for the years 1975 up to 2004. These are the data points that we will be graphing.
Okay, so our first step was to input all of our values into GeoGebra to form a scatter plot from the data on the table.
After doing the scatter plot, we graphed a normal cosine function on GeoGebra that we would then transform to align with the points. The regular form of this function is y equals cosine of x, and we would be altering it to fit the points.
And the symmetry axis. The symmetry axis is a line in the y-axis that represents the symmetry of the graph. To get the exact value, we use the minimum and maximum value of the table. Then we solve it, and we get the value. After doing this, we find that the equation of the symmetry axis is equal to, well, y is equal to 83.5.
The amplitude. The amplitude is how wide the curves of the graph are. To get the value of the amplitude, we take half of the difference between the maximum and the minimum values. By doing this, we found that the amplitude is y equals 74.5.
And then it comes the phase shift. The phase shift represents the horizontal shift of our function across the x-axis. In the case of a cosine function, you can figure out the phase shift by finding where the first highest value is located. By doing this, we found that the phase shift for this function was of 4.
The period. The period of a cosine function represents the length of a single cycle of the graph. To figure out the period, you double the difference between the time at the maximum value versus the time at a minimum value. Then, to figure out the k value, which goes in the equation, you divide the 2 pi by the difference. This gives us 12 as the period and pi over 6 as the k value for the equation.
Cosine model function. After figuring out all of these values, we combined all of them to form the equation that correctly modeled the data from the table. In this case, it was y equals 74.5 cosines p over 6 x minus 4 plus 83.5.
There were 2 problems at the end of the project that we had to answer based on our graphs and a model of the function.
The first problem asked us to find out how many sunspots were expected to be recorded in the year 2010. To find this information, we graphed a vertical line in the form of x equals 35, which is 35 years after 2010, the starting year. The intersection of both graphs showed that there would be around 19 sunspots in 2010.
The second problem asked us to find on what year and month there would be 135 sunspots recorded, similar to the previous process. We graphed a horizontal line in the form of y equals 135. From this, we found out that around the month of June in 1977, there would be 135 sunspots.
Thank you.